Welcome to this explainer. Let's just dive right in. Because right now, literally running through the walls around you, beneath the streets, and stretching across the entire country, there's a cinematic, invisible war taking place. On one side, we've got the perfect mathematical order of our electrical grid, and on the other, a chaotic, distorting force that is seriously threatening to tear that order apart.
I want you to imagine our power grid for a second. Think of it as a perfectly synchronized glowing pulse in the dark. In the UK, and honestly much of the world, that pulse beats exactly 50 times a second. It's this clean, smooth, absolutely perfect 50 hertz sinusoidal wave. Every generator, every transformer, even the digital clock on your microwave relies on that heartbeat being absolutely flawless. But right now, that pulse is under attack by a relentless, invisible force.
We're talking about harmonics. Harmonics are essentially the pure chaos in our grid story. By definition, they're currents or voltages at frequencies other than our perfect 50 Hz waveform. They circulate around the electrical system, tearing up the smooth waves and creating these jagged, distorted waveforms. And here's the ultimate irony. We are the ones injecting this chaos. Every single time we connect modern, non-linear loads, things like solar panel inverters, electric vehicle chargers, or variable speed drives, we are pumping these chaotic frequencies right back into the grid.
As you can see, the fundamental nature of our grid is changing, and that's exactly why this has suddenly become an emergency. We're transitioning away from big, spinning mechanical turbines and moving toward power electronics and converters, especially with wind and solar. But it's not just how we generate power that's changing, it's the physical infrastructure itself. To connect all these renewables, we're burying massive networks of underground cables. And those cables, they actually change the grid's impedance, acting like a giant amplifier for any of that harmonic chaos we just talked about.
So, to fight this rapidly amplifying chaos, grid operators are having to step up and enact incredibly strict new regulations. Take the UK's EREC G55 standard, for instance. It now mandates compliance assessments that analyze harmonic orders all the way up to the 100th order. Think about that for a second. That means engineers aren't just looking at the base 50 Hz frequency anymore, they are actively hunting down chaotic distortions at a whopping 5,000 Hz just to ensure the grid doesn't collapse. Section 1. Jamming the hidden signals, why limits drop to zero.
Let's look at the first major battleground in this war. Take a look at this comparison. Over on the left, you've got this beautiful, smooth sine wave cleanly crossing the zero axis. But on the right, look at those jagged, noisy lines. That right there is what harmonic disturbance does to a voltage waveform. And if you zoom in on that purple circle, you see a massive, massive problem. Instead of crossing the zero line exactly once, that jagged noise causes the signal to cross it multiple times in just a fraction of a millisecond.
Now, here is why that matters. Our massive multi-million-dollar power generators, they're effectively blind. They can't just see the 50 Hz frequency. Instead, modern generators and their voltage regulators look precisely at that zero crossing to calculate the AC line's frequency. So when harmonic chaos scrambles those zero crossings, the timing signals used by digital circuits, rectifiers, and inverters are totally destroyed. The equipment literally loses its timing and begins to misfire.
And this is exactly why, in certain scenarios, grid operators have to mandate an absolute 0% harmonic limit. Think of it like a critical military radio transmission. If you introduce even a tiny bit of static or jamming onto that exact frequency, the message is lost and the mission fails. In the power grid, those zero crossings are the critical radio signals. A strict 0% limit acts as an invisible shield, guaranteeing that these foundational communication signals aren't jammed by harmonic noise.
All right, Section 2. System strength, the river analogy.
So we know how harmonics attack the grid's brain, but how does the grid defend itself physically? Well, this brings us to a vital concept engineers call system strength and fault levels. To really picture this, think of the power grid as a flowing river. A strong grid with a very high fault level is like a massive, deep, fast-flowing river. If you dump a turbulent, rocky stream of harmonic chaos into that deep river, the river just absorbs it. The surface barely even ripples. But a weak grid, one with a low fault level, that's like a shallow creek. Dump that exact same turbulent stream into the creek, and the water violently splashes everywhere, flooding the banks. In our grid, that splashing is severe harmonic voltage distortion, which can overheat transformers and literally destroy equipment.
The really tricky part we face today is that our modern infrastructure choices are inadvertently turning our deep rivers into shallow creeks.
As we shift to renewables and rely heavily on long underground cables, we dramatically increase the grid's capacitance. This lowers our resonance frequencies, making the grid highly vulnerable to parallel and series resonances. Ironically enough, those old-school overhead lines are actually much safer when it comes to defending against these high-frequency harmonic attacks.
Moving on to Section 3, the physical trap, delta transformers.
Now, if the grid's natural strength isn't quite enough, engineers actually have to build physical traps to capture this chaos. And to understand that, we need to talk about a very specific, very dangerous enemy: triplet harmonics. These are the 3rd, 9th, and 15th order harmonics. Unlike standard harmonics that naturally balance out and cancel each other across a 3-phase power system, triplet harmonics are what we call zero sequence. They don't cancel out. Instead, they sum-mate. They add together entirely, flowing directly into the neutral wire of the system, causing immense overheating and major fire risks.
But this is where the engineering gets brilliant. Check out the triangle or delta-shaped winding connection here. This delta transformer acts as an ingenious physical trap for those triplet harmonics. Because of the way the copper coils are wired in a continuous loop, those dangerous zero-sequence harmonics go into the triangle and they get stuck. They endlessly circulate around the inside of that delta loop, physically canceling themselves out as heat. They are completely prevented from escaping back into the wider power grid. It is just an incredibly elegant physical solution to an invisible electrical problem.
Section 4. Restoring order, compliance, and mitigation. Of course, trapping triplets isn't the only tool we have. As grid operators enforce strict new rules like the UK's G5/5, engineers deploy a whole suite of solutions to restore order. If the grid is too weak, we can try to increase system strength or change the point of connection entirely. But usually we rely on active harmonic filtering, detune reactors, or high-pass filters. In fact, a recent study showed that integrating detune reactors with high-pass filters can drop total voltage harmonic distortion by a staggering 78%. That's a huge win.
Ultimately, winning this war requires a comprehensive defense strategy. It's a shared responsibility across the board. Data centers are upgrading to specialized, high-thermal class triangular core transformers that can handle the intense heat generated by these distortions. Developers are running highly advanced mathematical simulations, like Norton equivalent modeling, to map out harmonic impedance loci long before they even break ground. Compliance isn't just a checkbox anymore, guys. It is the fundamental shield keeping the grid alive.
Which leaves us with a pretty critical thought for the future. We are rushing headfirst towards a grid powered almost entirely by solar, wind, and battery storage. That means a grid dominated by the exact same inverters that generate this harmonic chaos in the first place. As we transition away from the heavy, spinning generators that naturally gave our grid its deep river strength, how will we engineer the next shield to protect that perfect 50 Hz pulse? The invisible war continues every second of every day, right beneath our feet. Thanks for joining me on this explainer, and I'll catch you next time.